Hello ma'am, my first question is how to draw indicator diagram for two-cylinder compound steam engine. Second question, solve one problem with the help of indicator diagram of two-cylinder compound steam engine.
To draw the indicator diagram for compound steam engine, let us first understand the concept of compound steam engine. An engine where the expansion of steam is taking place in more than one cylinder is known as compound steam engine. Cylinder which receives the high pressure steam is known as high pressure cylinder, or in short we will say that HP cylinder. Steam expansion is taking place and then steam is exhausted into larger cylinder, and this larger or the second larger cylinder is known as low pressure cylinder, or in short we will say LP cylinder. Now what is the theoretical indicator diagram for compound steam engine? So it is the graphical representation of variation of pressure and volume of the steam inside the engine. So for compound steam engine there are more than one cylinder. So we will say that there is the high pressure cylinder as well as low pressure cylinder. Now we will draw the indicator diagram for a given condition. So what is the given condition here? That is the two cylinders. So there are two cylinders. First one is high pressure and second one is the low pressure cylinder. Compound steam engine with complete continuous expansion in both the HP and LP cylinder. So the condition is that the complete and continuous expansion is taking place in high pressure cylinder as well as low pressure cylinder. So whenever the expansion is taking place, then there are two variables. That is, the first one is pressure and second one is the volume. So we will first take the high pressure cylinder. So we know that this cylinder receives the steam at high pressure. So whenever the pressure is high, that means volume is minimum. So we have to select one point for high pressure, that is we will say pressure P1, and the minimum volume, that is volume V1. So I will select here the point 1. So I will show here with the help of dot pressure is P1, and in the same way we will show the volume, that is volume is V1. Now we will move for the next process. So what is happening, as this high pressure steam enters inside a cylinder, expansion process is taking place, and this expansion is taking place with the law PV is equal to constant. That is, we will say pressure multiplied by volume is constant. So we have to draw that curve, that is PV is equal to C. So that is the given condition. So again I will show here, as expansion is taking place, that means pressure is getting decreased and the volume is getting increased. So we have to select the point in such a way that here this is the law, that is PV is equal to C. Now this is the point 2. So after expansion, here I will show that pressure is P2 and volume is V2. Now what is happening? This low pressure steam enters into low pressure cylinder, or we can say larger cylinder. So again the expansion is taking place. So here it is given that the complete and continuous expansion is taking place at LP cylinder, that is low pressure cylinder. So after that this steam is exhausted into the condenser. So we can say that in low pressure cylinder expansion is taking place up to the condenser pressure, or we can also say that is the back pressure, that is PB. So we have to show here the next expansion process in LP cylinder. So this total expansion from P1 to P2, this expansion is taking place in HP cylinder. So I will say here this is the process for HP. Now after that I will show the next expansion is taking place in LP cylinder with the same law, that is PV is equal to C. Now at this time after expansion pressure is getting decreased. So we have to show here the decrease in pressure. Now because the continuous and complete expansion is taking place, this pressure is nothing but PB, that is the back pressure. And what is the volume? So volume is V3. So this is the indicator diagram for given condition. Now we will draw indicator diagram for the second condition. Two cylinder, that is the compound steam engine with complete expansion in HP cylinder and incomplete expansion in LP cylinder. So here condition is given that complete expansion is taking place at high pressure cylinder and incomplete expansion is taking place in low pressure cylinder. So here we will take one pressure and volume. High pressure steam is getting admitted into HP cylinder. That's why here we have to show pressure of steam is high, but at the same time volume is minimum. So we will select one point. So this point will be at pressure P1 and volume V1. So here is the minimum volume we will show, that is the volume V1. Now the expansion is taking place, but here the complete expansion is taking place, and as per the law PV is equal to constant. So we have to show the expansion curve that is taking place in the high pressure cylinder. So I will show here PV is equal to C. So here after expansion what is happening? Pressure is getting decreased, but at the same time volume is getting increased. So I will show here the pressure P2 and volume V2. So this expansion is taking place in high pressure cylinder. So I will show here as a HP. Now this steam at pressure P2 is exhausted into low pressure cylinder. So again expansion is taking place in low pressure cylinder. But here it is mentioned that incomplete expansion is taking place. So here the pressure is getting decreased up to pressure P3 and volume is increased up to volume V3. So we have to show that. So the same law, that is PV is equal to constant. So PV is equal to C. So pressure is pressure P3. So this is the release point of pressure in low pressure cylinder, and at the same time volume is V3. But we know that after low pressure cylinder steam enters into the condenser. So that is the condenser pressure, or we can say back pressure. Now if we observe this diagram, here pressure is P3, but the final pressure, that is the back pressure, that we have to show. So at the same volume pressure is getting decreased, that is volume remains constant. So volume is V3 and then there is the back pressure that we have to show. So this back pressure is always minimum or is always lower than this pressure P3, because incomplete expansion in low pressure cylinder is taking place. So this decrease in pressure from P2 to P3 is taking place in low pressure cylinder. So I will show here as a LP cylinder, and then the back pressure we will show here, that is PB. So this is the indicator diagram for given condition. Now we will solve one problem. I will read what is the given question. A two-cylinder compound steam engine is to develop 90 kW at 110 rpm. The steam is supplied at 7.35 bar and the condenser pressure is 0.21 bar. The stroke of each piston is equal to LP cylinder diameter. The total expansion ratio is 15. Allow a diagram factor of 0.7. Assume hyperbolic expansion and neglect clearance and receiver loss. Determine the diameter of the cylinders so that they may develop equal power. So this was the given question. Let us first understand the given data. So this compound steam engine has to develop 90 kilowatt. That means indicated power is equal to 90 kilowatt. Then the speed is given, that is n is equal to 110 rpm, and the steam enters at high pressure in HP cylinder. So this pressure is nothing but pressure P1 7.35 bar. Now here the condenser pressure is given. That is, we can say that condenser pressure is back pressure, that is PB is equal to 0.21 bar. Then L, that is the stroke length, that is equal to diameter of low pressure cylinder. So we will use here the notation DL. So stroke length L is equal to DL, and then the expansion ratio R is equal to. Now this total expansion ratio is given. So if we observe, when the expansion process is taking place, then the volume is getting increased from V1 to V3. So total expansion ratio, that is capital R, we will say that it is the ratio of V3 by V1, and that is equal to 15. So we have to show that, and the value of K, that is 0.7. That is the diagram factor. So this is the given data, and the expansion process follows the law, that is the hyperbolic law. So we can say that PV is equal to constant. Now for this given data, we have to find out the diameters of the two cylinders. That is the diameter of the low pressure cylinder and diameter of the high pressure cylinder. So we will first find out the diameter of low pressure cylinder. Now why we are taking the first term, that is the diameter of low pressure cylinder? Because here the stroke length is equal to diameter of low pressure cylinder. So this is the condition that is given. So in the formulas, instead of L, we can use here the DL. Now we will first find out what is the area of low pressure cylinder. So what is the area of cylinder? So cylinder, that is, it is in the form of circle. So we will say that area of low pressure cylinder, that is pi by 4 dl square. Now what is the value of pi by 4? So pi by 4, so from the calculator we can easily calculate here, that is 0.7854 dl square. So instead of area of low pressure cylinder, that is instead of area A, we can use this 0.7854 dl square, and instead of L we can use this dl. Now we will calculate actual mean effective pressure. Now if we observe here, the expansion process is taking place, that is in HP cylinder and LP cylinder. So the actual mean effective pressure for the combined indicator diagram is always referred to the low pressure cylinder. So we will calculate this, that is the actual mean effective pressure referred to low pressure cylinder. So what is the formula? PA is equal to K P1 by R in bracket 1 plus 2.3 log R bracket complete minus PB. Now if we observe here, K, that is the diagram factor, is given, P1 and R is also given, then PB, that is also given in the data. So we will put these values. Now here pressure P1 and PB is mentioned in bar. So here is also actual mean effective pressure. So unit will also in same, that is the bar. So when we put the values, then we will get the answer 1.124 bar. Now it is given that the indicated power. So indicated power is 90 kilowatt. So we will again use the formula for indicated power. So formula is 200 PA/LAN by 60. Now if we observe indicated power is 90 kilowatt, then 200 multiplied by PA. PA, that is actual mean effective pressure, 1.124. Then L. So L is nothing but DL. So we will put here as a DL. Then A. So area of low pressure cylinder, here is the answer 0.7854 dl square. Then N. So N speed is given 110 divided by 60. Now if we observe this, only one unknown term is there, that is DL. So we can calculate this. DL is equal to 0.527 meter, and this is the diameter of the low pressure cylinder. Now we will move to calculate the diameter of high pressure cylinder. So here condition is given that this high pressure cylinder and low pressure cylinder has to develop the equal powers. So what is the condition for the equal powers? So condition for the equal power is given that 2.3 log of V2 square by V1 V3 is equal to 1 minus PB V3 by P1 V1. So this is the formula. So this formula is used for the power in high pressure cylinder, and this formula is used for the power in low pressure cylinder. Now these two powers are equal, so we have to equate these two equations. Now what is the area of high pressure cylinder? So we know that the area of high pressure cylinder, that is pi by 4 dH square. So dH, that is the diameter of HP cylinder. So 0.7854 dH square. Now we will move for the calculation. So 2.3 log of, now here V2 square divided by V1 V3. Now we have relation, that is V3 by V1 is equal to 15. So if we observe, we can put here or replace this V3 with V3 is equal to 15 V1. So this V1 we will transfer to the right hand side. So it will become V2 square divided by V1 into 15 V1, which is equal to 1 minus. Now value of PB is known, 0.21, value of P1 7.35. Now here the ratio V3 by V1. So V3 by V1 is nothing but the expansion ratio, that is 15. So we will put here, and we can solve here the right hand side, which is equal to 0.5714. Now again we will move for the next. So we will transfer this 2.3 to the right hand side. So on the left hand side, log of V2 square divided by 15 V1 square is equal to 0.5714 divided by 2.3. Now we have to remove this log. So how to remove the log? So for that we have to take anti-log on both the sides. So with the help of calculator we can take this anti-log. So if we observe, we have to take, suppose I have take here the anti-log, then this log is getting cancelled, and on the left hand side V2 square by 15 V1 square. And what about the right hand side? So here 0.5714 divided by 2.3. So answer is 0.2484. Now we have to take anti-log. So we have to take here shift and log, that is anti-log. So we have to press this shift button and log button simultaneously. So what is the answer? That is 1.771. So we have to take here 1.77. Now 15 I will shift to the right hand side. So 1.77 multiplied by 15, that is 26.57. Now I will take square root on both the sides. So square root on both the sides if we take, then we will get V2 by V1 is equal to 5.155. Now we will find out what is the ratio of volume of V2 and V3. Now why we are going to find out this ratio for V2 by V3? Because if we observe this diagram, the volume V2 is referred for the pressure P2, and that is the release point for the HP cylinder. So what is the volume at this point? So if we observe, this is the volume for the high pressure cylinder, and how to measure the volume? That is the area of the high pressure cylinder multiplied by the stroke length. Now in the same way, this volume V3, if we observe, is referred to for this pressure P3, and pressure P3 is the release point for the low pressure cylinder. So how we can find out this volume V3? So this is nothing but the area of the low pressure cylinder multiplied by the stroke length. So how to find out this V2 by V3? So we will take here V2 by V3 and we will multiply and divide with common factor, that is V1. Then how we will rewrite this? That is V2 by V1 multiplied by V1 by V3. So here if this V1 is getting cancelled, so this is both the meaning for the left hand side and right hand side remain same. Now V2 by V1, so we have already calculated the value of V2 by V1, that is 5.155. So we will put this value. Then V1 by V3. Now if we observe the given data, we have here V3 by V1. So if I take this V1 in the denominator, then for the denominator value is 15, that is 1 by 15. So when we calculate this, we will get the answer 0.3437. Now what is the meaning of V2? So V2, that is the volume of the high pressure cylinder, area of high pressure cylinder multiplied by the stroke length. So how we can calculate this area? That is, we know that pi by 4 dH square. So for high pressure we will use here the suffix h, that is 0.7854 multiplied by dH square. And for this V3, AL into L, that is 0.7854 into dL square. So this L is the common term that is getting cancelled. So here also 0.7854 common term that is getting cancelled. So dH square by dL square. So this value for V2 by V3 is 0.3437. Now it is easy for us to calculate dH because dL is already calculated. So 0.527 meter, this is the value of dL we will put here, and we will calculate dH, that is 0.309 meter.